Okay, and some of this stuff right here you'll see on when we get to final exam, you'll see some of this stuff here too. All right, so what I'm going to do is I'm just going to kind of quickly explain what we mean by exponential function. Exponential function would be something like you have a number to the x power. Okay, like that. We'll keep it kind of simple in this class right here, just any number to the x power. All right, without going necessarily through all these details, all this stuff, none of this stuff here will make much sense to you until we go over specific examples anyway. All right, so what I'm going to do is we're going to graph these two things right here just to begin with. All right, and we're going to do this without the calculator, then with the calculator. So you have to understand very clearly how exponents work. We did a quick review on that last class. So I'm going to have you fill out this table of values. You're just going to plug x in. So we're going to work out 2 to the 0, and we're going to work out 2 to the first, 2 to the second, 2 to the -1, and 2 to the -2 like that. Now we're not going to use our calculator to do those things because you don't need to. Some of them you can do in your head, all right? So I'll just kind of put this work over here at the side, and you don't need to write this down. Let's start with these right here. 2 to the second, what's that? That's 4, because that means 2 times 2. What's 2 to the first? 2. Anything to the first power is itself. This is the one students don't remember. What's 2 to the 0? 1. Some students remember, okay? So we got 1, okay? How about 2 to the -1? Okay, we talked about this last time. What it means is 1 over 2 to the first. If you have a negative exponent, it's not a negative number. It just means 1 over that number to the positive power. So that's 1/2. Okay, if you went to the calculator and put in 2 to the -1, you get 0.5. I don't want that. I want the fraction. 2 to the -2 is the same idea. That's 1 over 2 to the second. So that's 1 over 4. When you work out negative exponents, that's how you have to work those out. And there's a very logical thing on this too. If you think about it this way, if I divide by 2, 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is a half. A half divided by 2 is a fourth. So it follows that sequence, and it's very logical the way that goes. Right? Are you guys with me on those negative exponents? That's where students need the biggest review, is right there. Okay, those are fractional values. Okay, so what we're going to do next here is we're going to just construct a graph. So all you should have to do on your graph is just go out to 2 and then backwards to -2. And as far as the y-axis goes, you just need to go up to 4 like that. And then we're going to plot the points and connect the dots. And we'll kind of review this on the calculator. All right, so let's just put these points on here. You have a point 0,1, which goes there. You have a point 1,2, which is over 1 up 2. You have a point 2,4, which is over 2 up 4 like that. And then you have a point -1, 1/2. You just estimate where a half is. You've got a point -2, 1/4. Again, you estimate like that. So let me ask you a couple simple questions here. As x gets bigger this way, what's happening to the graph? It's getting bigger. So the bigger you go this way, the bigger it gets. How about this way? What's happening? It's getting smaller, but is it ever going to go to 0? No. Good. That's important. So like if you did 2 to the -10, 2 to the -10 is 1 over 2 to the 10th. It's not 0. It's just close to 0. So what's going to happen is the graph is going to approach the x-axis but never touch it. So your graph ends up on this, looking like this then. Okay, so you just kind of draw it like that, kind of draw it like that, and that's what your graph looks like. Okay, so let me show you how to put this in the calculator. And you want to understand how the numbers work instead of just putting it in your calculator all the time. So if you want to put this in the calculator, just put it in like this. You go to y equals, you put 2, and remember this caret key right here, right above your division symbol, does the exponent, and you just put x. And this button right here, xtn, puts the variable in automatically. So you go like that. So just 2 caret, and then like that. Okay, and then what we're going to do is on the window, if you go to your window button, let's just set it up kind of like this. I'll tell you what to do on this. Let's go -5 to 5. I'm just picking some numbers on this. And let's go for y minimum, let's go like -10 to 10. And then maybe scale that by 1. Okay, and then we can graph that. So you want to get the function put in, and then you want to get the window set up, and it'll have the same kind of thing. So if you've got the window set up, it's going to go like that. Exponential functions tend to get bigger as you go to the right, and then they level off towards the x-axis as you go to the left. That's the way they always tend to work, just a basic exponential function. So no, they never will. And the reason for that is even if you did like 10, if you did 2 to the -100, that's 1 over 2 to the 100. That's not 0. It's a positive number, but it's real close to 0. So I mean, if you put 2 to the -100 on your calculator, what you get is scientific notation. Okay, I'll show you what happens. Okay, that says 7.8 times 10 to the -31. You know what that means? It means if you go to the left 31 places, it would be 0, 0, 0, 0, 0, 0, 0, blah, 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 7, 8. Okay, so that's close to 0. That's the idea. Okay, all right. So again, you just put this in your calculator like this, like I showed you. 2 caret x is how you put that in. And then the horizontal asymptote is y equals 0. What the horizontal asymptote is just that x-axis. That's what it's leveling off towards. So it's leveling off towards y equals 0. Okay, and mainly what I want you to know on this is how I work with those exponents. That to me is the key thing. Okay. All right. Now what we're going to do is kind of repeat this graph and look at something else on here. So this one just says -2 to the x. So what the equation really is f of x equals -2 to the x. What it really means is that negative means -1 times 2 to the x. We've already done 2 to the x. Okay. You guys got any thoughts about what's going to happen to that graph if we just put that -1 in front? What's that? Yeah, it flips it over the x-axis. All the y-axis, all the y values go to opposites. So what I want you to do is this, because I want you to clearly understand how this goes. We already worked out 2 to the x. Just rewrite this, those numbers we already got. That would be a fourth, that would be a half, 1, 2, and 4 like that. Now what we do is we multiply each number by -1 because that's what that negative does. So that would now be -1/4, -1/2, -1, -2, -4. Okay, so and we've talked about this early in the semester about how transformations work. So what I want you to do on this then is just set this up like this. Just go from -2 to 2, and then just go up to 4 on the x-axis, and then down to -4 on the y-axis. Okay, and then what I'm going to have you do is just plot those points. Okay, so what we have is 2, -4, so that would be over 2 down 4, and then plot 1, -2, so that's over 1 down 2. Plot 0, -1, so that's like that. Plot -1, -1/2. And then -2, -1/4, like that. Again, you just approximate that. So yeah, that reflects that over the x-axis. That's the difference between those two graphs, okay? And we've learned some of this stuff, like I said, a little earlier in the semester. Again, well, I'm not going to do this one on the calculator, but if you did, this is what would come out. So you just put in -2, you do your caret key, x, and again, y equals 0 is the asymptote. What the asymptote means is horizontal asymptote. We've talked about that early in the semester. Just means what does it level off at? It levels off at y equals 0. That's the idea. Okay, you guys with me or not? Doing arithmetic and plotting points. That's what graphing is. Okay, if you want to simplify it as much as you can in your head, that's what it boils down to. Okay, all right. And again, we're kind of doing these problems mostly to review the transformations here. And then we're going to begin to get into some finance here a little bit today too. All right, so let's see. Yeah.
On the previous one, what about the part where it says /y1?
That's just how you put it in your calculator. So the calculator on a TI, usually it comes up like /y1. That's what that is. So I'm just what's that?
Is that like just what you would put in like the calculator to show?
Yes, yeah. What it is that the graphing calculator allows you to put several graphs in. So the way you would put this in is you would put your negative, use your negative key, then 2 caret to raise to the x power. So see that /y1 is just what's already there on your calculator. So I'm just kind of having you keep a record of how that goes. Well, there's the graph, okay? So it's going to match up, okay? Okay, let's take a look at this one. Now, again, what I'm going to have you do on this is we already figured out this information. The first graph that we already did this. We did 2 to the second is 4, 2 to the first is 2, 2 to the 0 is 1, 2 to the negative 1 is a half. We already did that. Okay, we're going to keep doing that on each of these problems. Okay, now what I'm going to do here is we're just going to crunch out some numbers on this. So I'm going to kind of do this like this. I'm going to start at x equals 2, and I'm going to plug that into this function. So I would really work out 2 to the 2 plus 2. That'd be 2 to the 4th. If you don't know what 2 to the 4th is, you just take 2 times 2 times 2 times 2. You would get 16. Okay, so that result would be 16. Because what you're doing is you're taking this x value, plugging it in when you work that out. Okay, now if we go to x equals 1, then it's going to be 2 to the 1 plus 2. Okay, 2 to the 1 plus 2 is 2 to the 3rd. 2 to the 3rd is 8. So it goes like that. You're going to see little patterns on these things as you go. Now I go to x equals 0. So now it's going to be 2 to the 0 plus 2. That's 2 to the 2nd. So that's 4 like this. Now let me show you how this works then. You can predict this in your head. You really can. 16, 8, 4. What do you suspect goes there? 2, right. I'm just dividing half, okay? So half, that would be 2. That would be what? 1, okay? I mean, you can number crunch every single one of those things out if you want to, but once you see the pattern, this is how exponential functions work. So that would be 2, that would be 1, like that, okay? Now, what I'm going to have you do on this one is, let's see, we're going to go ahead on this one, and let's just do the x-axis the same way. And this time, let's go up to 4 again. You don't have to worry about the negative y-axis, so it's not going to show up. This time, what I want you to do is 2 graphs, okay? And then you'll kind of see what's happening on this then. So let's graph the red numbers here. So we have 0, 1, we have 1, 2, and we have 2, 4. And this is the graph of y equals 2 to the x. Okay, now I just want you to kind of see if this rings a bell with you here. Okay, if we plot the rest of these points, we would have 2, 16, so that would be over 2, just throw a dot way up there. That's good enough. Okay, then we have 1, 8. So that would be over 1, up 8, kind of somewhere in there somewhere. And then we have 0, 4. So that would go like that. Then what we have is negative 1, 2. And then what we have is negative 2, 1. So this graph would kind of look like this. Okay, so this is what I want you to see on this. We learned this early in the semester. What is happening to this graph? It's going to the left, isn't it? Okay, so that thing is moving to the left, and that we learned about this early in the semester. Let me see if you guys remember this or not. Okay, y equals x squared. What does that graph look like? That's the parabola, right? That's what we learned early in the semester. So if you did something like y equals x plus 2 to the second, it just moves it to the left 2 units. Okay, if that was a minus, then it moved everything to the right. So what's happening on an exponential function, because that's a plus, that moves everything to the left. If that was a minus, everything go to the right. Okay, so we're going to kind of review some of these transformations as we do this then. Okay, and let's see, this one, of course, you just put in your calculator like this. You just do 2x, and then depending on what, if you have like an 83, does anybody have an 83? Then you need to use parentheses like that, because the way my calculator does is if I put this in my calculator, I'll go 2 raised to, and then I just put the x plus 2. So if you have an 84, you just put it in like that. Okay, and it'll give you the same graph that we just did. Okay. The horizontal asymptote's always going to be the same unless we do a up-down transformation. Okay, so one thing that you probably want to write a note is on this problem is this is taking you to the left 2. Okay, and we'll kind of review in just a minute here all these transformations. Okay, all right, so let's see. I'm going to do probably 1 or 2 other situations just to kind of get you through all the possibilities here. Okay, we're going to do the same thing on this one. We've already did this. That first row we've already done. We've done it on every problem. So just fill in those same numbers. We've got a fourth, a half, 1, 2, and 4, like that. And then the question becomes on this is, well, what are we going to do with that negative 3? See, we've already done 2 to the x, so what's that going to do? It's just going to add negative 3 to all those numbers. Okay, so if you were working that out, you would just go 4 minus 3 is 1, 2 minus 3 is negative 1, and so forth. So that's what you're going to do. This is going to do something to the graph. Okay, and you can do all this in your head if you want to. So basically, or you can just write a note to yourself on this. This would be 4 minus 3 would be 1, because I am adding negative 3 to it. 2 minus 3 would be negative 1. 1 minus 3 would be negative 2. You could use your calculator if you wanted to. If you did a half minus 3, that would be negative 2.5. And if you did a fourth minus 3, that would be negative 2.75. But you can do all that and get decimals on your calculator if you want to then. Okay, you guys see what I just did? Okay, I just take the 2 to the x and subtract 3. That's what the problem tells you to do. Okay, all right? Okay, so let's see. We'll put a 2 here, just kind of do the same thing and get your graph kind of completed. We can basically go up to 4 and then maybe down to 4. We do have some negative numbers in here then, like that. Okay, so I'll have you do the same thing. Graph the thing in red, the second row. Just do that again because I want you to see the connection between these. So we have a point 0, 1, 1, 2, 2, 4, and then it levels off to the x-axis like that. So that's the graph again of y equals 2 to the x. Okay, so what did that negative 3 do to the graph? Everything goes down this time, right? It doesn't go left or right, everything goes down. Everything gets smaller, so if you plot these points out, you would have 2, 1. So you want to plot the point 2, 1. You got the point 1, negative 1. So it goes like that. You've got the point 0, negative 2. Then you've got negative 1, negative 2.5. And then you've got negative 2, negative 2.75. So what happened is that graph, everything in that went down 3 units. That's what happens, okay? But what's new on this is the exponential function. The transformation is not new to us, okay? All right, now this time let me ask you a question, okay? On every one of these problems, y equals 0 was the horizontal asymptote. Not on this one. What do you think it is? There you go. Okay, this is going to level up at negative 3 because we're moving everything down 3. So what you would have on this then is that horizontal asymptote is y equals negative 3. So technically, what this means on this is it's just going to approach that line. It's never going to cross it, though. So if you go to the left, those y values are going to get closer to negative 3. So that's the idea. Okay? Are we clear or not clear? Okay, again, it's number crunching. Okay, it's arithmetic and points. Arithmetic and points. That's what always graphing at the basic level is. So I'm going to look at one other situation. This is the only other situation we need to look at. for these kind of problems. So we're going to do the same thing we've been doing. We're going to compare the basic function with whatever we're changing. Okay, so just write these same numbers like we've been doing. So again, we already figured out 1/4, a half, 1, 2, 4, like that. Now I'm going to show you how this works now. So what we're doing is we're doing 2 to the negative x. So I'm going to show you how the number crunching goes. And once you see this, you'll see a pattern to it. So if I plug -2 in there, I would get 2 to the -2. Well, what would that -2 become? 2. So 2 to the second would be 4. Okay, so what would happen is if x is -2, that becomes 4. Now then once I do a couple of these, I think you'll see what's going on in the problem, hopefully. Okay, let's go to x equals -1. Okay, then you would have 2 to the -1, because again, the problem says -x. So what's that going to get? That's 2 to the first, so what's that? 2. Okay, now remember I said these problems always have the same thing. Okay, that's 4, 2. What do you think that's going to be? 1, then this. Divided by 2. Half, then what? 4. Okay, it always goes that way. So what you're doing now on this one is you're doing 2 to the 0. That's 1. Then you're doing 2 to the -1, because you have that negative there. Then you're doing 2 to the -2. Okay, you can crunch them out methodically one by one, but once you see the pattern, it's pretty easy. So that's 4, 2, 1, 1/2, 1/4, like that. Okay, well, let's put this together and let's see what happened on that graph then. Okay, so again, I'm just going to have you plot the original. So we've got, let's see, 0, 1, 1, 2, 2, 4, and just kind of repeat what we've been doing. Okay, so that's y equals 2 to the x. And then I'll do the rest of them like this. So now what happens is we have -2, 4. So you go left 2 up 4. You have -1, 2. You still have 0, 1. And then you have 1, 1/2. Then 1, 1/4, like that. So that graph is going to go like that. Well, what happened? It reflected, but which axis did it reflect over, x or y? Over y, exactly. Okay, so this one is a reflect over the y-axis. All depends on where you put these numbers. Yeah. No, but I have no choice but to teach it. Okay, and you'll get it like anything else. Okay, right? I can't review the whole time because I have to cover the curriculum, so I have to do this. All right, so again, you would put this in like this. You would put in 2 to the -x. The horizontal asymptote's y equals 0. Okay, like that. Okay. Okay, so I'm going to do on the next page, we'll kind of go through the transformations. And then what we'll begin to look at is we're going to do a little bit of finance in here too, because we'll start getting into that a little bit. All right, so on this next page, I'm going to get a little bit into the graph of e to the x. Now, when you study finance, this number e is really a big deal. It's a big deal in finance. It shows up all the time. Okay, so if you don't know anything about the number e, I'm going to show you kind of where that comes from. All right. So the idea with this is that Euler is kind of a famous mathematician. He's the person who came up and discovered this number e. And e is kind of like pi. It's an irrational number and the decimals repeat and everything. Well, let me show you what Euler did. Okay, you don't have to know all the math. I went in and just did the math, you know, so you can kind of look over this. So the idea is what Euler did is this is his idea. In his time, we already knew what compound interest is. We had banks and stuff that use compound interest. So his idea was, I'm going to invest $1 as the starting principal. I'm going to have an interest rate of 100%, and I'm going to see what happens to my money after a year. Okay, so let me show you what happens if you use the compound interest formula. And we're going to get through, learn how to do the compound interest formula a little bit today. So what you do is that compound interest formula is the principal P, that's what you give the bank, and then it's 1 plus APR is just the interest rate, divided by N is the number of times you do interest in a year, and then it's the number of times you do interest times the time. So I'm going to show you what he did on this. Now, there was no calculators in the 1700s, so I had to do this by hand. So anyway, he takes $1. That principal is going to be $1. Then he does 100% interest. If you have 100% interest, then it would be, you move the decimal back to the right too, so it would be 1. Just like probability 100% is 1, okay? He's only going to do interest one time at the end of the year, and the time is going to be for 1 year. So in the compound interest formula, what you do is that's the money you put in the bank. That's your principal. That's the interest rate. It's 100%. That's why I put a 1. That's the number of times you do interest. That's what yearly interest means, is you do interest one time at the end of the year. And then that's always going to be the time like that. So what happens is if you work this out, you would get 1 times 2 to the first, so that would be $2. So at the end of one year, his money is doubled. That's what would happen if you put $1 in a savings account that pays 100% interest and does interest one time, okay? Your money doubles. That's how that goes, okay? Now, what I want to show you on this, and I'm not going to do every one of these, I'm just going to give you kind of the idea on this, is you can also do interest quarterly. Quarterly means 4 times. It means you're going to do it 4 times in a year. So that would go like this. Again, that's your principal, $1 there. Now it's 100%. Interest is 4 times. Now that's 1 times 4. Okay, so you're doing the 4 times 1. Now so if he did his interest quarterly, it would be $2.44. Okay, that's the idea. If you go on to monthly, you have $1, 1 over 12. You're doing interest 12 times. Now it's $2.61. Okay, so here's what happens. The more often you do your interest, what's happening to your money? It's getting bigger, right? Okay, the more often you do interest, the more money you're going to make, but it's not going to get infinite. Okay, if you did interest every second of a year, you're not going to get an infinite amount of money. You get something around $2.72. So what happened is when Euler did this, he began to discover that this thing is approaching a certain value, and the value of E, we call it E because it's named after Euler, whose last name begins with E, is a number that's approximately 2.7182, and then the decimals repeat forever like pi does. So in mathematics, the most famous irrational number is pi. The second most famous is E. Okay, so E is also an irrational number. That's where that comes from. So if you're not really clear yet on the mathematics of compound interest, that's what we're going to get to here in a few minutes anyway. My thing that I want to show you is if you invest $1 over a year, the more often you do the interest, the more money you make. And you should know that pretty much already. So, but it doesn't get infinite, it just gets close to that number. Does that make sense? That's what E is. A lot of times teachers teach what E is, but hardly ever teach where it comes from. That's how we discovered E, is from that. Okay, that's the idea. Okay, so this kind of gives you an approximation. I want to show you one thing on your calculator. Okay, so do this on your calculator. If you look at your calculator, you should find, if you look at your division symbol, you should see the letter E above that division symbol. So one thing that you want to do on this is, if you go in a clear screen, if you go second and then division symbol, E comes out, press enter, well, that's the number. The decimals go on forever, but that would be just sort of an approximation of what E is, okay? So that's the idea. It's just like pi, it's an irrational number. So the purpose of that page was mostly to show you where that comes from. Okay, so what I want to do next here is do a graph of e to the x, which is going to be very, very similar to the graph of 2 to the x. Okay, so we're going to do a little bit of number crunching on the graph of e to the x. So what we'll do is we're going to do this. We're just going to replace x in the exponent. So we'll have e to the negative 2. We'll have e to the negative 1, e to the 0, e to the first, e to the second, and so forth like that. But what we're going to do is we're going to do decimal approximations on this. Okay, so basically what you would get here is what's anything to the 0 power? What would e to the 0 be? Okay, anything to the 0 power is 1. Okay, e to the first is e, but e is about 2.7. So I'm just going to have you put 2.7 like that then. Okay, e to the second would be, what that would be is about 2.7 to the second. So I'm just going to do that on the calculator. Okay, just to give you an estimation on that. So what you can do on this is you can go like this. You can go second e to get that to come out. Then you can go to the second power. There's more than one way to put that in your calculator. So that's about 7.4. So let's just record that as about 7.4. Okay. Now I'm going to do like e to the negative 1. So I go second division symbol like that, raised to the negative 1. I'm just going to get a decimal on this, and that's going to be about 0.4. Okay, starting to get into smaller and smaller numbers, and I'll do the next one the same way. E to the negative 2, I'm just going to put my calculator. So I go second division symbol, raised to the negative 2, and then that'll be about 0.1, roughly like that. Now, all those numbers are just coming from my calculator. We're going to plot just to get an idea of what this stuff looks like then. Okay? What's that? Like this. Okay, so I go second division symbol to get the e. Raised to is that key. Then negative 2. Put the negative and then the 2. Yeah, like that. So it's 0.1. Okay. Now the graph of this is going to look a lot like the graph of 2 to the x. So we're going to estimate this. So just do this on your graph. Get everything set up the same way we did on the previous problems. And we probably need to go up to about 8 on this. So 1, 2, 3, 4, 5, 6, 7, 8. Just extend your graph like that so everything will fit. So what we have is we have a 0.01. That goes there. We have a 0.1, 2.7. We have a 0.2 and then up 7.4. And then these values here are just decimal values that are getting close to 0. So the graph has that same structure to it as all these problems do. That's how exponential curves go, is they tend to start that way and then they zoom out that way unless there's a transformation like that. So that's the idea. And then that one is something you want to be familiar with because in finance, E shows up all the time in formulas in finance. Okay, there's a specific kind of compound interest formula. The loan formula has E in it. The annuity formula has it in there. So it's something that anybody who's dealing with finance needs to know something about. Okay, so what I want to kind of run through here next is just the transformations of how this goes. And I want you to know a little bit about the transformations. So when you have an exponential function, it basically looks like this. These are all the possible numbers that you can have in here. So you want to kind of know what each number basically does then. Okay, and we've talked about this stuff before. So one thing that we can do on here is, let's start with A. Okay, what A is what that does is that multiplies y by A. So what it does is that's what we call a vertical stretch or shrink. And we have talked about this before. We have. I don't know if you remember much about it or not, but we have. Okay, let me give you an example before I move to the next thing here. Okay, y equals x squared. Everybody remember that's a parabola, hopefully, right? What if I did y equals 2x to the second? What that does is it makes all the y values get bigger, so it stretches it. I like that. We learned that. Let me show you this basic idea here. Okay, and just watch this, okay? If you put in x to the second on your calculator, and if you did a standard window, you could go zoom 6. That's a parabola. We learned that earlier. If I go and do this, if I go to y2 and put in 2x to the second, look what happens. Okay, see how it stretches it? All the y values get bigger, so it stretches it. That's what's happening when you do that. If I open up my table of values, I want you to see what happened on this, okay? That's y equals x squared. See how those numbers double? 1632, 2550? That's what causes it to stretch. So when you put a number in front of a function, that's what it always does, okay? Now let me show you one other thing. And you just watch this. You don't have to do this on your calculator. What if I put in 0.5x to the second? That wouldn't stretch it anymore. What it would do is it would shrink it, okay? And that's because the y values would get smaller, okay? So check this out. See what I mean? Okay, all the y's got smaller, they flatten, so therefore they shrink. Okay, we learned that a little bit earlier in the semester, okay? All right, let's see. The next thing is C. Okay, now what C does is that basically it's a horizontal. I'm not going to worry too much about this one either. This one is a horizontal stretch or shrink. And it ends up just kind of being the opposite on that. I'm not going to pay too much attention to that one in this class, though. Okay, and let's look at the next one here. The D, if that's inside the exponent, D is going to be left or right. It's going to move your graph either to the left or to the right. Okay? Now remember, we did this before, so I want to just kind of use my calculator to visually at least demonstrate this to you. Okay, so I'm going to go back and do this. Okay, and I think you guys will remember this okay, hopefully, anyway. I already reviewed this a little bit. So what if I did x minus 3 to the second power? What would that do to that parabola? What did we learn? What did we learn? Right 3, right 3, right 3. If you're inside the function, it's left or right. Okay, so notice what happens. There's my original parabola. That goes to the right 3. Okay, so what's going to happen on this is if you have a minus, it goes to the right. If you have a plus, it goes to the left. Okay, so that just, you got to see where that falls in an exponential function. Okay, then the next thing we learned is this. Okay, like for instance, if you had this, and all functions work the same way. So if I did something like this, if I did x squared plus 3, what happens to the parabola? It goes up 3. Okay, like that. If I did minus 3, it would go down 3. So it depends on where that number is. So in this case, it works the same way. That e, what that's going to do is it's going to take you either up or down. If it's plus, it takes you up. If it's minus, it takes you down. Okay, like that. All right. So that's what that stuff means. And then the other thing that we learned was this. I'm just using the parabola as an example because we have a little bit better background for it. All right. So if I did this, if I did negative x squared, then what happens to the parabola? This way, reflect over x. Okay. So if this number a is negative, then that's going to reflect over the x-axis. Okay, and then I'll show you this one, the number c, since it's in front of x, that reflects over y. Now, I want to go back before I go to the next page, I want to show you that we really looked at almost every one of these things in the graphs that we were doing. So I want to go back and kind of review that then. So basically on an exponential function, those numbers work the same way they do on all functions. It's all the same, okay? Let me go back to kind of reviewing the graphs that I did here. So just kind of look at these. Okay, so if you look at this one right here, we know 2 to the x goes like this. When we did negative 2 to the x, what happened? It reflected over the x-axis. So if you make that number negative, it reflects it, okay? Just like it would on a parabola or any other function, okay? Look at this one. We did 2 to the x plus 2. What happened to that one? Left, okay, it went to the left. So it all depends on where that number is. If that's inside the exponent, it's going to go left or right. Okay, so that's left 2. Depends on where that number is then, okay? And this one, we had 2 to the x and minus 3. What did that minus 3 do? Brought everything down 3. Okay, if that was a positive 3, everything would go up 3, like that. And then example 5, I had 2 to the negative x. Well, that reflected the graph over y, because what it's doing is it's making the x values go to opposites. Okay, that's what's happening in that problem then. Okay, right? Okay, so that's what we're going to do is kind of just see how many of the transformations we can do then. And just see how many of these we can identify. Okay? All right. So when we do this then, on this, okay, we have a plus 2. Now, e to the x, the graph of e to the x looks like that. We did that. What does the 2 do? Goes up. All of the y values get bigger, so it goes up 2. Okay? Okay, how about the next one? Negative 4. You're making all the y values get smaller, so what happens to the graph? Down 4. Okay? You'll only remember this stuff if you understand the arithmetic. Okay? What that's doing is it's making y bigger or y smaller. Okay? All right, how about the next one? Okay, I got x plus 3, but it's inside the exponent. So what does that do? Left or right? Good. Okay, so that is left 3, like that. Okay, how about the next one? It's inside the exponent, so what? Right 2. Okay? So it depends on where it is. That's changing x values. It's making the x values change. Okay? All right, the next one. I have a negative. So what does that do? Okay? It makes the y values go to opposites, so therefore it reflects over y. Okay? Okay, again, it matters where the number is. That's the thing. How about if I put the negative in the exponent? Then what happens? Reflects over the y-axis. So the first one is reflect over x. This is reflect over y. Again, you won't remember any of this stuff at all unless you understand why it works. Okay? Here's how I know this stuff, by the way. Okay, I understand the arithmetic. And you can too. What's happening? If x goes to opposite, what happens? X over here goes over there, right? Okay? What this does is this makes y opposite. So if y is up there, y goes down there. Okay? You got to understand the arithmetic. That's the reason we did those examples where you could see the numbers. Okay? Okay, how about this one? Okay, what's happening is I'm making the y value double. I'm multiplying the y values by 2. So what happens? Stretch, okay, this way, vertical stretch, okay? So that's going to be vertical stretch. Okay, and that's because the number is bigger than 1. Okay, the next one, I'm taking the y values and making them get smaller. So what happens if the y values get smaller? You shrink. Okay, that's because it's a fraction. It's making y get smaller. So that's a vertical shrink. Okay, this next one, I got a crazy one here. I've got all kinds of things going on this. This is just kind of seeing how well you can put all this together now. Okay, let me start here. I'm adding 7 outside the function. What does that cause the graph to do? Up 7, okay? So that takes care of that. Okay, I'm subtracting 2 in the exponent. What does that do? Right 2. Okay, now I'm multiplying by 1/4. I'm making the y values get smaller. So what does that do? Shrink, shrink, shrink. Vertical shrink. And it does, that's the other thing. There's 4 transformations. So what you have here is you would have vertical shrink. Okay, and then the last thing is reflect. There's a negative there. So that would be reflect over the x-axis. Okay, so that's how that goes. All right, so that's kind of a summary of that, and it works the same way on all functions. So that's not really brand new or anything. This is just kind of a summary that I've shown you of how the numbers go. Okay. Okay, let's go ahead and break here till 5 till, and then we'll do the finance next year. Finance will seem a little bit more practical, but all the finance has to do with exponential functions. That's why we go through it. Okay, so let's take a break. Solid with here. So I'm going to go over the compound interest formula. Let's get our phones away. I see a lot of people on phones today here. Put them away. My phone's away. If I don't text and look on Facebook, you shouldn't either. So get them away. Okay? No phones. Thank you. Okay, so I'm going to show you how the compound interest formula works. And so in the formula, I showed you a little bit with the Euler number. So we're going to learn how to use this. The principal is what money you put in. Then you have an interest rate, which is R. And then M is the number of times you compound in a certain amount of time. And T is the amount of time. Okay? So what we're going to do is just kind of start simple here and put everything in. So on this example 8, this is how you should start the problem. You want to write down the compound interest formula. Okay, so A is equal to the principal P times 1 plus the interest rate over M, which is how many times you do compounding, which is told in the problem, and then MT, like that. Okay? All right, so let's get everything plugged in. The principal is 10,000, so that goes there. Okay, so that'll go there. Then you got 1 plus. Okay, the interest rate is 2.5%. Now, when you use the compound interest formula, you got to move that decimal back to the left 2 places. So you'll have 0.025 like that. If you don't move the decimal back, you're going to be getting ridiculous amounts of money in your savings account. Okay? All right, well, here's the key. Compounding monthly. What does that mean? Every time a month goes by, you do interest. So there's 12 months in a year, so that's why you divide that by 12. Okay? If it's compounded daily, then you do 365. If it's compounded quarterly, that's 4 and so forth. So you got to know what those things mean. What you do in the exponent is what you do in that exponent is you're telling me basically how many times do you do an interest over 10 years. So if you do interest 12 times a year for 10 years, you're going to do interest 120 times, right? So again, what you're doing is principal goes there, interest rate goes there, monthly, that's why that's a 12, and then 12 times the number of time like that. Does that make sense? It's all just a matter of knowing what everything in this formula means. And then we're going to do this on our calculator. I don't expect you to do this any other way other than your calculator. So get your calculator out and do these with me. Make sure you know how to do this. And these modern calculators, you can do it in one step. Okay. So what you can do is just put it in exactly like this. You put in the 10,000, then you put a parenthesis. You don't have to put the times. Then you do 1 plus 0.025 and then divide by 12. Okay, then close the parenthesis like that. Then you do your exponent key. So you do the caret key like that, and you can either put 120 in or you can do 12 times 10. It doesn't matter. The calculator is going to follow the order of operations for you fine. And then you can press enter, and then that'll give the amount of money that's in that account at the end of 10 years. Okay, so what this is giving you is that amount is $12,836, and I'll always round to 2 decimals since we're talking about money, so that's the amount right there. So what that means is your money that started at 10,000 and it grew to 12,836. So how much interest did you make just in your head? You can do this in your head on this problem. Exactly, right. You went from 2,000 to 12,000, so you made $2,836.92 off of interest alone. Okay, so that's how that works out. Okay? All right, so we're just going to learn how to crunch out the numbers in this formula primarily. We'll work with this a little bit different ways a little bit later. So again, with this one, same thing. We can go ahead and just plug in. I like to just write down the compound interest formula as I do these, though. Okay, so this will go like this. The principal's $500, so that goes there. Your interest rate's 12%, so what are you going to use in your formula? Not 12, but what? 0.12, right. You got to move the decimal to the left 2. Okay, so you're going to have 1 plus 0.12 over m, okay? Now, what it says is compound daily. So what do you think I use for m? 365. Sometimes, and you might see this in some of your business classes, sometimes they'll tell you to use 360, okay? I don't remember how our book does that. It'll kind of follow that. I'm just going to use 365 on that. But sometimes the standard is just to use a 360-day year, okay? And then the exponent goes like this, okay? You're doing interest 365 times, but you're doing that for 100 years. So basically, you're doing interest 36,500 times. And the more often you do interest, the more money that you earn off of that investment then, okay? All right, so again, we're just going to put this in one step on the calculator. So you can go exactly like this, and just make sure that you do this on your calculator and let me know if you have any problems with that. So I do 500 parentheses 1 plus 0.12 divided by 365, close the parenthesis, and then raised to the 365 times 100. Let's see, if you have a TI 83 like I think you said you had, you would probably have to put that exponent in parentheses. So I think if you got TI 83, you got to do that. There's your answer. Wow, is that right? Well, it's 100 years. Yeah, okay, that's pretty wild, but that's what it is, okay? Okay, who's going to put $500 and come back 100 years later, though? And nobody's going to pay you 12% interest. There's no bank out there that does that on a savings account. You can do an online money market and make maybe about 2.5%. That's about the best that you can do, and that, from what I know. So anyway, that would be, guys, is that in the millions? My God, that's 81,217,063.8. Well, okay. Well, one thing that I want you to make, there's a connection I would like you to make, really. Okay, exponential functions go like that. So the further out you go, the bigger it gets, the faster it gets. So interest works like an exponential curve. So the bigger the interest rate, the further out you go in time, the more that you're going to get, and you're going to get at an accelerating pace like that. Okay, so that's the idea. All right, so don't be surprised at those numbers sometimes. Okay, let's put this one together. One more like this. So this one is a little bit different. And this problem says, how much should you put in a savings account at 2.5 compounded monthly to end up with $20,000? Okay, so this one you have to do something a little bit different on. So again, I would start by writing down my formula. And then we're going to try to get everything kind of put together like this. Now, this time it's different. This is not the principal. What is that? That's the amount after interest. Okay, I'm saying how much do you put? That's what principal is. So that we don't know P, we know that. Okay, so you have to read that problem carefully and know that then. So when you set this up, it'll go like this. $20,000 is A. P is what we're going to find. Then the rest of it's all the same. We would say 1 plus, okay, what are you going to use for 2.5? Okay, move the decimal to the left, 0.025. Says compound monthly, so what do you use? Use a 12, okay, so we do 12. And then the exponent would be 12 times the 10 years, like that, okay? Well, the way you got to do this one on your calculator, you have to solve an equation. So let me show you what you probably ought to do on this then. So what I would do on this one is just work this part on your calculator. Just do this part only to start with. Do this in 2 steps. So I would just go like this. I would go 1 parenthesis 1 plus 0.025 divided by 12, and then raise that to the, and you can do that in your head if you want to, that's 120. So do that, and then I'll record that. And I would use every decimal that comes out on my calculator. You know, just to be safe, don't round stuff off because that'll affect your money amounts quite a bit. So we'll just write that as 1.28. That's what I have is I have the principal times 1.28, 3691542 like that. All right. Okay, well, we've done algebra earlier this semester. This is an equation. What do you do to both sides of this equation to get p by itself? You divide by that thing, right? Okay. You don't have to write that step on your paper necessarily. You just kind of go like this. You can if you need to. So you're just dividing by that number. But use all of those decimals when you do that. Now, here's the simplest way to do this. This is what I would recommend you learn how to do. Your calculator will have, if you look at your negative key, above it in blue or some color, it's going to say ANS. That's an answer key, so it works like a memory key. So what you could do is you could go like this, 20,000. And if you want to, if you could either type all those numbers out or you can go like this, second, negative, and ANS has that previous calculation stored in it anyway. So if you do it that way, that saves you a little bit of time. So what this would tell you then is the principal is about $15,580 and about 7 cents. So that's how much money you put in the bank that will grow to $20,000 in 10 years. So that's the idea. Okay, so you have to solve an equation on that problem when you do that. Okay, does that make sense? Okay, I'm going to let you guys do some work. Okay, if you got phones out, put your phones away and let's do 2 problems, just 2 problems. I'll walk around and see if you're on track on this stuff. So I would suggest that you write down the formula as you're doing these and use your calculator, see how you do. If you don't have a calculator, borrow one. And we'll kind of compare our answers to see if we're on the right track. I think I've given you one of each problem. I think one of them you just, plug in the numbers, do the number crunching on the calculator, and the other one